Episode 4, the last of the series, I'm afraid. Breaks my heart, but I will try and do this one justice. Episode 4 is all about gravity. Why do we care about gravity? Well, I'll tell you why we care about gravity. Because this happens. My headset falls to the ground, gravity makes it fall to the ground, which is a great shame, but this happens in my real-world deployments, so my device better be rugged enough to survive that fall. So our device is obviously designed for a lot of ruggedness. How do you even start designing for this sort of drop? By the way, does anyone here have a phone? Would like to drop the phone in comparison? I'm guessing not. Nobody really wants to drop their phone, do they? So, okay. All right. So we designed this beast to be a 2-foot drop onto concrete resistant. What does that mean? Well, we have to go back a few hundred years. And we see our friend Sir Isaac Newton, 350 years ago, started figuring out all this stuff about gravity, and he came up with these equations of classical mechanics. And there's two that we use today, even. Anyone remember this from their high school days? V equals U plus AT, which actually tells you how fast things get with an acceleration applied to it. And then the second one, S equals UT plus a half AT squared. That tells me how far something goes at a given acceleration and starting velocity. So just for fun, we plugged in those numbers into our system to come up with this. For a 2-meter drop onto concrete, it takes 0.6 seconds for our headset to hit the concrete. And when it hits the concrete, it is traveling approximately 14 miles per hour. Whether that's useful or not, I'm just throwing it your way, put it in your back pocket. It's good to know, right? So our device is designed for that. It's also designed for a whole bunch of other stuff. We design for the arm rotation. We do thousands of rotation per device. We rotate around the optic pod, round and round. We've got machines that do this thousands of times to make sure it works. The camera up and down. And we even bend this thing out. And we twist it and bend it and do all sorts of horrible, nasty things to our device. This thing is flexible and rugged. And it has to be. We do vibration testing and even temperature testing, where we'll drop this into minus 40 degrees, and we'll bring it out to 50 degrees, and we'll make sure this works. So the bottom line is, this is deployable in all those industries we've seen on stage today. And it's about the only device I know that can really survive these forces of nature.